Chinmay, on 28th of Feb, which was Saturday, we found something that went on to become one of the biggest vulnerabilities in authentication package in Java. I would love to know how the hell did you find it?
So it started with a normal PR review. One of our devs was adding a login to a Java backend using pac4j. It's one of the most popular Java security libraries. Code was clean, followed the docs perfectly, but CodeAnt flagged something on the authentication config.
Okay, what did we flag?
So the way JWT login works, think of it as two layers of protection. Layer 1 is encryption. It locks the token so only the server can read it. Layer 2 is a signature. It proves the token is real and hasn't been tampered with. You need both. Our engine said there's a scenario where layer 2, the signature, never gets checked.
Okay, what do you mean by that?
So when you log in, the server checks two things. Can I decrypt this token? And is the signature valid?
Okay.
Think of it like an envelope with a wax seal. The server opens the envelope, great. Then it checks the seal. But what we found is if you send an envelope with no seal at all, the server does not reject it. It
Okay.
just says that, hey, okay, no seal, moving on, and accepts everything inside as real.
Okay, so if I send a token with no signature, the server
The
will
server
actually
trusts
does that.
completely. Yeah,
Okay,
the server trusts is completely.
okay. And that is why this is actually a CVSS 10 score. We got a perfect 10 on 10. Nothing to brag, but this is a bad one. No, nobody should get that. So, in a nutshell, to encrypt that token, all you need was server's public RSA key, which is actually public by definition. Like every server or most of them openly expose that. So now an attacker can just take that public key, create a false token, and say like, "Hey, I am the admin," and it will wrap in the encryption token, send it to the server, and server will decrypt it and see that there's no check, and they will say, "Okay, welcome." And this is actually an
Yeah,
attacker entering, correct?
correct. No password, no hacking, no brute force, just a public key that anyone can find.
Wow. And this was sitting for how long, like in that package?
So sitting for like 6 years across three major versions of the library.
That's crazy. Guys, this became the CVE 2026-29000, a CVSS score of 10, the maximum possible score that you can get. And it all started with a pull request review that our AI code reviewer did.
Yeah, that's the scary part. Our developer did everything right, followed the official docs. The vulnerability wasn't in his code, it was in the library itself. If we hadn't flagged it, it would still be there.
That's crazy. That's crazy. So we found the vulnerability. We told the world it's going like a fire. People are picking it up. What is the next thing that we can do? Should we release a checker that scans their S bombs and stuff and give them alert real quick and they can upgrade the package? What do you think about that?
Yeah, we are in the process of writing a scanner that will check your repository for all the dependencies and transitive dependencies as well, and it will flag whether you are using an insecure version of pac4j.
Crazy. Let's do that. We'll keep you guys updated on how this vulnerability evolves. And this was an amazing find. Thank you for your time, Chinmay.
Thank you.